everyone, if you've been enjoying my free math lessons on Prodigy Mathematics, I've got a great way you can support the channel and supercharge your learning. I've launched Martian Mathematics, a growing collection of problem sets, quizzes, and fully worked out solutions designed to complement my videos. These aren't just generic worksheets. Each set follows my lesson structure, reinforcing key concepts with carefully crafted problems and step-by-step solutions. Every purchase helps keep this channel running, so I can continue bringing you high-quality, free math education. Check out Martian Mathematics on Teachers Pay Teachers today. Your support makes all the difference. And don't forget to like and subscribe. Lecture 13, Decimal Division and Percents. So, let's say you took a test that had 40 questions, and you got 34 of those questions right. How do you figure out what your score is? Well, you got 34 out of 40 questions. So we're clearly going to divide 40 into 34, yes? But how do we actually do that? Well, let's first remember that a fraction, like say 1/2, is really a division problem. It's saying 1 divided by 2. It's a proper fraction, so it's less than 1. So we can write the answer in decimal notation, but let's see how we do that. Let's go ahead and express 1/2 as a division problem. It means 2 divided into 1. Now, of course, if we do this division problem like we've done it in the past, we would say, well, it goes into 1 0 times. 0 times 2 is 0. 1 minus 0 is 1. So we have a remainder of 1. So we would write this as 0 remainder 1, which is the same thing as the fraction 1/2. So what can we do differently using the decimal notation? Well, for starters, we can put a decimal point after the 1, because 1 is the same thing as 1.0. We'll go ahead and put a 0 here too. Now, with division problems involving decimals, it's important to remember to line up the decimal point underneath the division symbol with a decimal point in the answer. So we're going to put our answer decimal point right here. Now we divide as normal. So we say, well, 2 into 1. Well, it goes 0 times. 0 times 2 is 0. 1 minus 0 is 1. Drop down the next digit. Now I have the division problem 2 into 10 to consider. How many times does 2 go into 10?
5 times.
5 times. So I write a 5 right here. 5 times 2 is 10. 10 minus 10 is 0. I have a 0 remainder, which indicates, just like before, that we're done. So we get that 1/2 can be expressed as the decimal 0.5. That wasn't too bad, was it? So let me give you one to try at home. I want you to express the fraction 1/4, or 1 over 4, as a decimal. Pause the video, do that now, come back when you've got your answer. Okay, so this begins by setting up the division problem. 4 divided into 1.0. Let's go ahead and put our decimal in the answer section above the division symbol. 4 goes into 1 0 times. 0 times 4 is 0. 1 minus 0 is 1. We drop down the next digit. 4 goes into 10 2 times. 2. 2 times 4 is 8. 10 minus 8 is 2. Drop down the next digit, but we don't have another digit. But we can just simply add another 0, because 1.0 and 1.00, same number. Drop that 0 down. How many 4s go into 20?
It's
5. 5 times 4 is 20, leaving a remainder of 0. And so we have found that 1/4 can be written as a decimal 0.25. So you see, we've kind of done the opposite of what we did in the last lecture. In the last lecture, we took a decimal number like 0.25, and we expressed it as a fraction. Right? We would have said, okay, 0.25, that's 2 over 10 plus 5 over 100, which is the same thing as 25 1/100ths. And then we would, of course, reduce. We'd say, well, 25 times 4 is 100. So we can rewrite this as 25 times 1 over 25 times 4. The 25s cancel, and we're left with 1/4. And so now we see how we can go the other way. We can start with a fraction and go to a decimal. Now I want to look at a fraction which results in slightly different behavior than what we just saw. Let's consider the fraction 1/3. And I would like to express this as a decimal. So I'm going to set this up as a division problem. I'm going to divide 3 into 1.0. I'll make sure I put my decimal point in the answer section of my division above my division symbol. And then proceed as before. So 3 goes into 1 how many times?
0.
0 times. 0 times 3 is 0. 1 minus 0 is 1. We drop down the next digit. 3 goes into 10. How many times does 3 go into 10?
3.
3 times. 3 times 3 is 9. 10 minus 9 is 1. Since we don't have a 0 remainder, we'll go ahead and add another 0 and drop it down. Now we say, well, 3 goes into 10. Wait a minute, haven't we done that before?
Yeah.
We just did it, right? And we know what's going to happen. We're going to get 3 goes into 10 3 times. We'd write 3 here. And 3 times 3 is 9. 10 minus 9 is 1. We drop down another digit. And we're doing the same problem over and over again with no end in sight. It seems to be repeating. 3's all the way down forever, right? It never is going to stop, yes? Now, oftentimes the way that we write this 3 repeating is like this, 0.3, and we put a bar over the top of it. So when you see something like this with a bar over the top of it, that means that the digit is repeating forever. So it's 0.33333333 till the end of time. Weird, huh? Let me give you one to try. Okay, express 2/3 as a decimal. Pause the video, come back when you get that done. Again, we're going to set this up like a division problem. 3 divided into 2.0. Put our decimal point in the above in the answer section. How many 3's go into 2? 0. As long as this is a proper fraction, the first digit here before the decimal point is always going to be 0, because proper fractions are less than 1. 0 times 3 is 0. 2 minus 0 is 2. Drop down the next digit. How many 3's go into 20? Something times 3 gets close to 20. Yes, 6. 6 times 3 is 18. 20 minus 18 is 2. We would drop down the next digit, and we would have to divide 3 into 20 yet again. We would get 6 again. So we see what's happening. If it repeats once, it's going to continue repeating forever. Okay? So once you start seeing this repetitious behavior, you know that you're done. And you can just simply put a bar over that saying it's 0.6 repeating forever. And so 2/3 can be written as 0.6 repeating forever. Sometimes you're going to see it written like this. Just a heads up, especially with a calculator. So if you punch that into your calculator, would someone like to punch that into the calculator? Type 2 divided by 3. What does it say?
6 repeated.
No, does it really say 0.6 with a bar over it?
0.666666667.
How many 6's?
1, 2, 3, 4, 5, 6, 7, 8, 9.
And then what?
A 7.
And then a 7. Okay, so his calculator output this. So what happened here with this last digit, right? You see that it's got the 6 repeating, right? So if we were to stop at any point along the way here, let's say that we decided we were going to stop, say, in the 1,000th place, right here. Okay, so that's what we have to do, and what your calculator is doing is it's rounding that, okay, to the 1,000th place. And so what do? We say, well, this is approximately 0.66, and then this digit here will either stay 6 or become 7 if the neighbor is 5 or more. Is the neighbor 5 or more?
Yeah.
Yes, it is. So we're going to round it up to 7, you see? And so that's what the calculator is doing. So if you punch these into a calculator, you'll often see something that looks like this, and what's going on there at the end is rounding, which we talked about in the last lecture, I believe. You're probably thinking, this is awfully strange behavior, this stuff that's like repeating forever. And I would propose that every number that we've written down here is such a repetition. Remember at the beginning we found that 1 over 4 was equal to 0.25.
Yeah.
Well, what is the difference between 0.25, where you have zeros repeating forever, yes, after that, and 0.249 repeating forever? So I would propose that this number and this number are exactly the same number. if they weren't the same number, you would be able to find a number that's bigger than this and smaller than this one. But you can't. There is nothing. So 0.9 repeating forever is the same thing as 1. Now, isn't that interesting? So all these fractions that we've written down, we could have written them down in one of two ways. Like this, typically we don't write the 0 repeating, it's just understood. Or we could write 0.249 repeating. 1/2 could be 0.5, or it could be 0.49 repeating. Anyways, that's just a bit of an intellectual curiosity. You're welcome to think about that more if you like. It's kind of a deep or deeper thought, but I thought it was interesting nonetheless. Okay, now I want to give you a list of special fractions that you should memorize because they'll be used so often in your mathematical life that they're well worth knowing. So I'm going to just write a table of them down here. 1/2, 0.5, 1/3, 0.3 repeating, 2/3, 0.6 repeating, 1/4, 0.25, 1/5, 0.2, 1/6, 0.16 repeating, right over here, 1/7. This one is a strange one, okay? 0.142857 repeating. All of those digits repeat. So after this, it would be 142,857, 142,857, 142,857. But then we have 1/8, which is 0.125, 1/9, which is 0.1 repeating. So you encounter these fractions in decimal form often, and they're well worth knowing. Additionally, we have 1/10, which is 0.1. We have 1/100th, which is 0.01. And I could even throw in there 1/1000th, which is 0.001. But of course, these we know because we talked about them last time, right? This is the basis for our place value system, right? 1/10, that's the first digit to the right of the decimal point. 1/100th is the second digit to the right of the decimal point. 1/1000th is the third digit to the right of the decimal point. And you can continue on. You can do 1/10,000th, 1/100,000th, 1/1,000,000th, and it's just going to keep adding more and more zeros between the decimal point and the 1. This, by the way, is why we were able to simply add a decimal point to the dividend when we turned a fraction into a division problem and got a decimal answer. Putting that decimal point in, right, the reason we could do it is because each place value differs from the next by a factor of 10. And so it works going to the right as well as to the left of the decimal point. One more thing to note about these numbers that I've written up here. Anytime we take a fraction, either a proper, improper, doesn't matter, and write it as a decimal, it's always going to either terminate, like 0.5, or repeat, like 0.3 repeating. Not all numbers do this, right? So 1/2 is 0.5, and 1/3 is 0.3 repeating, but numbers like pi, which I can really only say are approximately equal to 3.14159, and so on and so forth. They never stop, they never terminate like 0.5 did, and they never repeat. There is no section like with 1/7 that you can find which is going to repeat over and over and over again. Okay? So that's a key distinction between what we call rational numbers and irrational numbers. Okay, now that we've mastered turning fractions into decimal numbers using long division, let's flip the script and start with decimals directly. So this is really no different, but let me just show you what I'm talking about here. So if I said, what is 3.6 divided by 4? So let's set it up as a division problem. So we'll divide 4 into 3.6. Don't forget to write the decimal point in the answer section directly above the decimal point in the dividend. And then we proceed just like we did before, right? How many 4s go into 3? 0. So we write a 0 here. 0 times 4 is, not 4. 0 times 4 is 0. 3 minus 0 is 3. Drop down the next digit. How many 4s go into 36? Something times 9. divided by 9. 9 times 4 is 36, leaving me a remainder of 0, which means that I am done. So this is equal to 0.9.
Why don't we put the decimal point there?
What?
Why don't we keep the decimal point there?
Here or here?
In 3.6.
I keep it there so I know where to put the decimal point in the answer section. The answer section decimal point is anchored to the dividend through this decimal point. Okay? So unlike multiplication, where we just completely disregard the decimal point when we multiply, and only after we've multiplied and added up the individual terms do we come in and ask how many digits were behind the decimal point. With division, we want to keep track of the decimal point. Okay? Kind of like we did with addition and subtraction. Okay, let me give you one to try. So go ahead and pause the video and try 7.5 divided by 5 at home. Okay, we're going to divide 5 into 7.5. We'll start by putting our decimal point in the answer section directly above the decimal point in the dividend. 5 goes into 7. Well, this time it's not 0 times, right? It's at least 1 time, yes? 1. 1 times 5 is 5. 7 minus 5 is 2. Drop down the next digit. How many 5s go into 25? 5. 5 times 5 is 25. I get a remainder of 0, and so I am done. And we have found that 7.5 divided by 5 is equal to 1.5. Let me give you another problem to consider. Let's do 4.2 divided by 0.7. Now this is different because it's the first time we've seen a decimal for the divisor, right? So how do we approach that? Well, basically the bottom line is we don't want to do long division with a divisor that is in decimal notation. We always want to make our divisors whole numbers. Now, is there a way we can turn 0.7 into a whole number?
Divide by itself.
Well, yeah, okay, that would turn it into 1. That's true.
Multiply it by 10.
Multiply it by 10. Another way to write this is as a fraction. It's a little weird, and we never think of it as a fraction. We always think of it as simply a division problem. 4.2 divided by 0.7. But let's think about it for a moment like a fraction. Now, if I were to multiply the denominator by 10, that would certainly turn the 0.7 into a nice whole number, 7, right? Because multiplying by 10 moves the decimal point 1 to the right, as we learned in the last lesson. But it would also change the fraction, right? We never took fractions and only multiplied one part of the fraction by some number. We would multiply times 1, yes? Because multiplying times 1 doesn't change the number. 3 times 1 is still 3. Pi times 1 is still pi. And 4.2 divided by 0.7 times 1 is still 4.2 divided by 0.7. So I can multiply by 1, but I get to choose the form in which I write 1 because it's a fraction. So I can write 1 as times 10 divided by 10. That's 1.
Yeah.
So what does that turn my fraction into? It turns it into 42 divided by 7.
Yes.
It doesn't matter that I got rid of the decimal point here with 4.2. In fact, I could write it in because we've already done long division where we had a dividend that had a decimal in it, right? So that's not of concern to us. But the fact that we now have the divisor as a whole number is what we're looking for. And so that is going to be our trick. But of course, when we divide by, and we're never going to do anything other than multiply by 10 or 100 or 1,000. So really this all boils down to moving the decimal point. So what we can do is if we move the decimal point 1 to the right in 0.7, then we have to do it 1 to the right in 4.2. So we can do it like this. We can say this is the same thing as 42.0, if you want, divided by 7. For the reasons that I just showed, right, with a fraction. So now I can write this down as a division problem, 7 into 42.0, if you want. How many times does 7 go into 4?
0.
0 times. 0 times 7 is 0. 4 minus 0 is 4. Drop down to 2. How many times does 7 go into 42?
6 times 40.
6. 6 times 7 is 42, leaving me a remainder of 0, which means that I'm done, right? So leading zeros we don't need to write. We can erase that there. And we don't even really need to write the 6.0 afterwards, right? We can just truncate the whole thing right here. And we're done. And so we see that 4.2 divided by 0.7 is 6. Now, I could test this by actually multiplying 0.7 times 6, couldn't I? We already know how to do decimal multiplication. Let's go ahead and check it. 0.7 times 6. Remember, we don't even have to worry about the decimal points, which means I don't even have to write in that like this. I can just say 7 times 6. What's that equal to? Well, it's equal to 42. And then I say, well, how many digits did I have behind the decimal point?
2.
No, I had 1, because it was 0.7 with 1 digit behind the decimal point, and 6, which has no digits behind the decimal point. So just 1, which means I need 1 digit behind the decimal point right there. Okay? I could write the decimal point back in if you want. Put 0.7 like that. So 1 digit behind the decimal point, and there's our answer. So we've confirmed. Let me give you one to try. I would like you to divide 3.15 by 0.05. So go ahead and pause the video, try that one now, come back when you've got your answer. Okay, so you see what we need to do here, right? We need to move the decimal point 2 places to the right so that we can have a divisor of 5, yes?
Yeah.
But we also need to move the decimal point 2 places to the right here in the dividend. So that's going to give me 5 divided into 315, and then we'll put the decimal point right there. So how many times does 5 go into 3? That would be 0. 0 times 5 is 0. Drop down the next digit. How many times does 5 go into 31? That would be 6. 6 times 5 is 30. 31 minus 30 is 1. Drop down the next digit. How many times does 5 go into 15? That would be 3. 3 times 5 is 15, so I get a remainder of 0, which means I can just lose the decimal point here at the end. I can get rid of the leading 0, and I get that 3.15 divided by 0.05 is equal to 63. Now, it's not always going to divide a whole number of times, as these examples did. You could have a decimal point answer, and you will in your homework. I can promise you that. But the important thing to remember here is that when we move the decimal point in the divisor so that we can get a whole number divisor, you have to move the decimal point in the dividend an equal number of times. Don't forget to do that. That's important. All right, the last thing I'd like to talk about is percents. Percent literally means, I think percentum means per by the hundreds, okay? And you've probably seen the word, the prefix cent in words like century. How long is a century? Anybody?
10 years.
No. 100 years, exactly. So percent means, think of it like per 100. So if somebody writes down 25%, what does that mean? All we have to do is recognize this means 25 over 100. That's literally what it means. Now, we can write this as a decimal as well, right? What's the decimal version of 25 over 100? Well, we just have to divide 25 by 100. Each time we divide by 10, we move the decimal point 1 to the right, or excuse me, 1 to the left. So we can think of this as 25 with a decimal point right here. Dividing by 100 moves, we're going to divide by 10 twice, so it moves once, and then 2 times, so this is equal to 0.25 as a decimal number. So let me ask you at home to write 7.5% as both a fraction and as a decimal number. So pause the video, come back when you've got your answer. So the fact that there's a decimal point in the percent, don't worry about that. All we have to do is remove the percent sign and move the digit over 2 decimal points. But you'll notice that we don't really, after we move it over 1 decimal point, we're out of digits, right? So go ahead and add on another 0 in front of that 7. So when we move the decimal point over, 1, 2, we have a digit to jump over, right? And so we'll get 0.075. But that's, of course, that's the decimal number for 7.5%. Don't make the mistake of writing it as 0.75. That is not what it's equal to. What number is that?
That's 3/4.
That's 75%. So don't make that mistake. So now that we have it in decimal notation, it's pretty obvious how we can write this as a decimal, as a fraction, right? Because we've got 75, and it's in what place? That's the tenths, hundredths, thousandths. So we can write that as 75 over 1,000. What if I wanted to convert a decimal number, like 0.4, into a percent? How do I do that? Well, my suggestion is to first write it as a fraction whose denominator is written in terms of the hundredths place. Okay? And so how would we do that? We would say, well, that's just 40 over 100. That's why I wrote the extra 0 here, so I had a digit in the hundredths place. So 0.40 is the same thing as 41 hundredths, which of course is 40%. Yes?
Yeah.
Not too bad, right? Let me give you one to try. There, let's try that. 0.423. Write that as a percentage. So pause the video, come back when you've got your answer. Okay, so the first step, I said let's write it in terms of a fraction with a denominator of 100. So we're going to focus on the hundredths place right here. So if it wasn't for that 3, we would just write that it's 42 over 100, right? How do we deal with this 3? Well, it's not that bad. We just write 42.3 over 100, which means that this is equal to 42.3%. Yes? Okay. So not terrible. So how do we use these percents? What are they good for? Have you ever looked at a receipt and wondered where the weird extra cents came from? The sales tax at the bottom, 7.5%, 8.25%. It isn't magic. It's percent math. And you can calculate it yourself. All it takes is a good grasp of decimals and percents. Right? You go to a restaurant, you get a bill, and you want to leave a tip. Let's say you're going to leave a 15% tip. So I've got an $80 bill, I'm going to leave a 15% tip. How much money am I going to leave as a tip? Well, it's 15% of 80. Well, what does that mean? So 15% times, let's say $80. What we want to do is we want to convert our percent into a decimal number. And then we can multiply our decimal number times 80. So what is 15% as a decimal number? 15% is equal to 0.15. Yes?
Yeah.
So to solve this problem, we need to multiply 0.15 times $80. So that's going to be 0.15 times 80. 0 times all of these things is just going to give me a row of zeros, right? Now the 8 tens, I'll add a 0 and then do 8 times 5 is 40. 8 times 1 is 8 plus 4 is 12. And then 8 times 0 is 0, so I'll just ignore that. Add all these up, I get 1200. I had 2 digits behind the decimal point in my problem, so I need 2 digits behind the decimal point in my answer, so it's equal to $12 and 0 cents. So that's how much tip we would leave. That's 15% of an $80 tip. If you wanted to try and do it in your head, right, 10% of an $80 tip, what is 10% of 80? What is 0.1 times 8? 80? 8, right? And then half of that, what is half of 8?
4.
And what is 8 plus 4?
12.
Yeah. So 10%, then take half of that, add it to it. That's, now it's 15%, and so you can get 12 that way. But let me give you one to try. Okay, your total bill is $45, and you're going to leave a 20% tip. So how much is that in dollars? So pause the video, try that at home, come back when you've got your answer. Well, 20 as a decimal number is 20 over 100, which is the same thing as 0.2. And we're going to multiply that times 45. So I could put the 45 up here, I suppose. 2 times 5 is 10. Carry the 1. 2 times 4 is 8, plus 1 is 9. And there's no reason to work with the 0. It's just going to add a bunch of zeros to it. So we have 90. We got 1 digit behind the decimal point, so we put the decimal point right here. So that means that our answer is $9.00. So that's percent problems. And I'll put a variety of those in your homework. Just remember that percent problem means some number over 100. The number in front of the percent symbol is the number that you put over 100. So if it was 20%, that's 20 over 100, which is just 0.2, because we know how to divide by 100. That's just moving the decimal point to the left 2 times. Also, always remember to convert to a decimal number before doing multiplication when you're using percents. Percents show up everywhere in tips, test taking. So what does it mean when you get 100 on your test? It means you got 100%. So what would the answer be? We had that question at the beginning where we had 34 right out of 40 questions. So 34 right out of 40 questions. What grade does this person get? Well, first thing we're going to do is we're going to divide 40 into 34. We'll put the decimal point here. 40 goes into 34 0 times, obviously, leaving a remainder of 34, which means now we have to divide 40 into 340. 40 times 10 would be 400. So we're going to guess that this is somewhere around like 8 or 9 times we can get in there. So let's try. What is 40 times 8? 8 times 0 is 0. 8 times 4 is 32. That's 320. What about 9? 40 times 9. 0. 9 times 4 is 36. That's 360. So that's a little bit over. So we can get 8 in here. 8 times 40 is 320. That leaves a remainder of 20. So we're going to need to drop down another digit. All right, how many times does 40 go into 200? Well, what? Yeah, it's 5 times, right? So here's a 5. 5 times 40 is 200, leaving a remainder of 0, which means that this 34 out of 40 questions is equal to 0.85. So what's their grade? Well, 0.85 is the same thing as 85 over 100, which is the same thing as 85%. So the traditional way that grades are reported in terms of percentages, 34 out of 40 correct would be an 85% score. So today we learned how to convert fractions into decimals, which is different than what we did last time where we converted decimals into fractions. And then we looked at decimal division, first in a simple case where the dividend is the only place where a decimal is present, a decimal point is present. But then we extended that to when there is a decimal point in the divisor as well. And we learned that we have to move the decimal point to make the divisor a whole number before we do the division. Aside from that, it's just division as we've done it before. We just have to remember to line the decimal point up in the dividend with the decimal point in the answer section above the division bar. And finally, we look at percents, what they are, how to work with them, how to go from percent to decimal to fraction, and back and forth again. Next time, we'll look at ratio problems.